So we're going to take a look at arithmetic sequences. Some of you have seen them in Algebra 2, but some of you have not. So an arithmetic sequence basically is a sequence with a common difference between terms. Really, it's a constant rate of change. It's like a linear function. D is known as that common difference. So there's a closed, your book also calls this explicit formula, and there's recursive. So there's two different formulas that you need to be familiar with. When you're doing the closed formula, it's going to be A sub n. So A sub n, remember, just means it's a sequence, equals. You're going to tell the person what to start on. So it's your first term of the sequence. You're going to tell them what to add or what to subtract each time, and you're going to do it n minus 1 times. So I think this will make more sense when I show you a couple examples, but that's the general form for a closed formula for an arithmetic sequence. So what about recursive? So recursive, it's like telling a story. So a sub k equals the term that comes before it plus the common difference. And you also need to tell the person who's reading this what to start on. All right, so let's do an example so that you can see how both of these formulas look. So for -1, -6, -11, I think you can see that you're subtracting 5 each time. So your common difference is 5. How would that look as a closed formula? So I would say, hey, this is a sequence. So a sub n equals, what term am I starting on? I'm starting at 4, and I'm subtracting 5 n minus 1 times. Why is it n minus 1 times? Well, I don't want to subtract 5 the very first time, because then I wouldn't have 4 as my first term. See how when I plug in 1 right here, 1 minus 1 is 0, 5 times 0 is 0. I'm not subtracting anything, so I just get 4 as my first term. Then when I plug in 2 here, 2 minus 1 is 1, so I'm just subtracting 5 once. And the recursive formula, a sub k equals a sub k minus 1 minus 5 each time, and I need to tell it to start at 4 for the first term. It says use the closed formula to find a sub 15. So I'm going to take 4 and subtract 5 times 15 minus 1. So I'm just plugging 15 in for n. So 4 minus 5 times 15 minus 1 comes out to -66, and it asks you, why is the closed formula more efficient than the recursive formula? If I wanted to find the 15th term, I would have to generate term 1, term 2, term 3, term 4, term 5, all the way up to term 15. The closed formula, I can just plug in the number 15 right there. Find the common difference for each of the following arithmetic sequences, find a closed formula, and use it to find a sub 8. So 7, 11, 15, 19. What's the common difference each time? It's going up by 4. So if I write my sequence, I'm starting at 7, I'm adding 4, n minus 1 times. Now I want to find a sub 8. So I'm going to plug in 8 where I see n and evaluate it. So 7 plus 4 times 8 minus 1 comes out to 35. So you should pause it and try example 3 and then see if you get it right. So let's see, my common difference is I'm going down by 5 each time. So a sub n equals 2 minus 5 times n minus 1. When I plug in 8, what do I get? So 2 minus 5 times 7, -33 is what I get. All right, so how about a couple little bit trickier ones where we have to use the common difference to come up with the formula. Find the closed formula for an arithmetic sequence if the fourth term is 20, 1, 2, 3, fourth term is 20, and the 13th term, So this is the 4th, this is the 13th, is 65. So here's how you're going to do it. How many terms did you go up by? You went up 9 terms, and you went up a total of 45 total like spaces. What's 45 divided by 9? 5. So your common difference is 5. We need to find our formula. So I need to go backwards, subtract 5, subtract 5, subtract 5. Now I know my starting term. So my formula is start at 5 and add 5, n minus 1 times. Now I can plug 20 in to see what I get. So when I plug in 20, 5 plus 5 times 19, I get 100. And a shortcut, when the difference is the same as the starting term, I really could have just written 5n right here, because 5 times 20 is 100. But this is the long way. That's the closed formula. So I would pause it, try 5 and 6 before I show you the answers and see if you can get them. All right, recursive formula. Second term is 8, 12th term is 28. 12th term is 28. I went up 20 and I went up 10 terms. So it looks like my difference is 2. A sub k equals ak minus 1. I'm adding 2 each time, and I need to tell it to start at, let's see, the difference is 2, second term is 8, so it must start at 6. And list the first through the 5th term. So 6, 8, 10, 12, 14 would be the first 5 terms. Given this sequence, determine whether 82 is a term in the sequence, and if it is, which term is it? Well, let's write a formula. This would be 6 plus 4 times n minus 1. Can that ever equal 82? So we just solve for n. So I would take 82, 82 and subtract off 6. 4 times n minus 1 equals 76. I'm going to try dividing by 4. N minus 1 is 19. So n would have to be the 20th term. Let's just plug in 6 plus 4 times 19 is 82. So yes, it's the 20th term. So that was just kind of an overview of arithmetic sequences. I'd like you to try the guided practice on the back and see if you can practice writing some formulas, finding some common differences, writing some terms. There's a couple application problems at the bottom. Let me know if you need any help or have questions. You just need to submit the guided practice.